Hello, in this lecture we will discuss something really important. This is that message sends are plans for reuse. And this lecture is related to previous lecture on sending a message is making a choice. And the self-semantics that you already saw in the previous lecture. This lecture is relevant to any object-oriented language, even if we will use Pharo as usual in this MOOC. And this is another essential aspect of object-oriented design. So what you will learn in this lecture, this is that message sends are hooks for subclasses. And message sends are places where code of subclasses can be invoked. So let's dig into it. Let's start with simple thinking. Sometimes you may hear some anecdotes like, I like big methods because like that I can see all the code in one place. Or I do not like small methods because the code is scattered in different methods. And the questions are, why large methods leads to under-optimal design? And why writing small methods is a sign of good design? And we will try to answer that by looking at examples. So remember, when you send a message to an object, you are making a choice because the system will select the right method to execute, given the receiver that will receive the message. And the choice, you express as a programmer the choices by adding classes in the hierarchy. Each class represents one possible choice. And self is always represents the current receiver. This is the object that will receive the message. And the method lookup starts in the class of the receiver. This is automatic, except for supersend that you already saw in another lecture. So given all of that, here an example. So we are in a node class, and in this class there is the method setWindow with ratio for display. And the question is, what are the possible solutions to change the default node size formula in subclasses? If I want to define a new subclass of node that change this expression and only this expression here, what can I do? Solution 1, I can duplicate the code. So for example, here I start by creating a new subclass, node with margins. Okay, this is a new subclass of node. And now I can redefine this method. I will copy paste all the code and I change this expression by adding a margin. So clearly, this is a bad solution. So why is it bad? This is a bad solution because when you are duplicating code, you are copying bugs. So if there is a bug in the superclass code, you will copy the bug inside the subclass. And if you want to change the code, it means that you have multiple copies, so you need to change everywhere. In some languages, such as Java, using the private keyword prevents duplicating the code because some instance variables are not accessible in the subclass. So this is something that you should take into account. So what is the essence of a better solution instead of duplicating code? This is something that we already saw in previous lectures. So the idea is to define small methods and to have a hierarchy of classes. For example, here I define a new object. This is an instance of C, the C class, and I send it a bar message. So if you remember the lookup, so it means that the method is lookup in the hierarchy chain, and then we will find the bar method in the A class. It will be the code of this method is doing a self send here, self foo, and there is a default foo implementation in A, but foo is redefined in the C class here, and this message send will correctly return 42 because the foo method will be correctly resolved in the class of the receiver. Now let's apply this to our example. If I come back to my method here, so this is the original method. Now I can completely apply this pattern. I can isolate the expression here in a self-sum ratio, okay? and I can implement a ratio method in the node class here with the default expression. And now what I'm able to do in a subclass, for example, if I have a node with margin class, which is a subclass of node, it means that I can redefine the ratio method. I can, using a supersend, call the super method to reuse the code, the default implementation of the ratio, and add a margin of 10. So in the general way, there is no need to invoke the super implementation. This is just because in this case we want to extend it. So we reuse the default implementation and we add a new margin. Okay. So now I have a new subclass that can use the regular method setWindow with ratio for display, but it will use a different ratio that has been refined in the subclass. Another step. Now we have this version of the method in the node class, and the question is how to use a different UI node in subclasses. If I want to create a new subclass that do not use a UI node instance, but a new class, another node, another kind of node, how to do that? You should think 1 minute on your side, and the answer is to use exactly the same pattern. So now we can extract exactly the same way this instance creation into a self method, into another method here, create UI node, that I can implement in the node class. And here I have exactly the same expression as before. I instantiate a UI node, but now it opens the door to redefine this method in a subclass. For example, in a subclass, I can redefine this create UI node to change it. But I can even do better. What I can do is that I can here isolate the name of the class in another self-send, the UI node class here. So it means that I can directly return the name, the class UI node. So now subclasses just need to redefine the UI node class and not the whole expression. It's not mandatory to redefine the create UI node, the whole method. So this is a good practice to define methods that return classes. It helps a lot extensibility in subclasses by redefining it. And it's really easy in Pharo because classes are regular objects, but this is not the case in all languages. So there are many takeaways in these lectures. So you should remember that small methods are a good sign of good design because we give name to the expressions. We saw it with the ratio or with the creation of a UI node. They encapsulate some complexity. And if we give a nice name to methods, it means that it's easier to read for the programmer. It is testing, because if I have smaller methods, it is easier to write tests to test specific portion of the code. It supports self-send messages. Like that, it opens the door for subclasses to redefine part of the behavior. So it means that there are potential hooks for subclasses. So if you look at it, object-oriented programming is a kind of emmental-oriented programming. This is a Swiss cheese in which we have holes like that, and holes are filled up by subclasses. In fact, in superclasses, we already create holes with self-send messages that will be filled up or will be adapted by subclasses. So in conclusion, code can be reused and refined by subclasses. Sending a message to self in a class defines a hook, and subclasses can use this hook to inject variations. So at the end, prefer small methods in your code. It gives names to the expressions, and each message to small method is an extensibility point for subclasses.